Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 8-1. The statement is a spherical gas tank has an inner radius of 1.5 meter. If it is subjected to an internal pressure of 300 kilopascal, determine its required thickness if maximum normal stress is not to exceed 12 megapascal. So let's start with the given data. In given data, it is given that it is a spherical gas tank. So spherical gas tank having inner radius Ri is equal to 1.5 meter. If it is subjected to internal pressure of P is also given, that is equal to 300 kilopascal. Clear? Determine its required thickness if maximum normal stress, that is maximum normal stress should not exceed, means it can be equal to 12 megapascal or less than 12 megapascal. So it should not exceed 12 megapascal. So what you have to find is that you have to find the thickness T. So let's start with the solution. As we know that spherical gas tank is given, so its allowable stress is given by the formula, that is P into R divided by 2T, and this R is inner radius. Clear? So P into Ri divided by 2T. Now we have all P, the internal pressure, we have the internal radius, we have allowable stress which is maximum 12 megapascal. So from here you can get this T is equal to this T is equal to P into Ri divided by 2 into allowable stress. So you can put the value P is equal to 300 kilopascal, so 300 into 10 raised to power 3. Ri is 1.5 meter and divide by 2 into, we have allowable stress is 12 megapascal, so 12 into 10 raised to power 6. So when you calculate it, this T will be equal to 0.0188 meter, or if you further simplify, it will be equal to 18.8 millimeter. So this is the required thickness of this spherical gas tank. I hope you have learned from this video. Now we will move toward another problem, that is problem 8-2. So again here in given data we will write given data a pressurized spherical tank. So again this is spherical tank and that is pressurized. Clear? Is made up of 0.5 inch thick steel. So here thickness is given as 0.5 inch. Clear? If it is subjected to internal pressure of 200 psi, so internal pressure is 200 psi pound per square inch. Determine its outer radius if normal stress is not exceed to 15 ksi. So allowable or maximum stress is equal to 15 ksi. So what we have to find is, again we have to find its outer radius, which is R outer. Clear? So let's start with the solution. So as we know that for spherical tank we have allowable stress is equal to P into R divided by 2T, where P is the internal pressure, R is inner radius, T is thickness, and sigma allowable is the maximum stress. So from here you will get the R which is the internal radius, and that R is equal to 2 into T divided by 2 into T into sigma allowable divided by P. This will give you R. Now you have the value, you have 2 multiplied by thickness is 0.5 inch, clear, and allowable stress is 15 ksi, so 15 into 10 is to power 3, clear, divided by pressure is 200 psi. So when you calculate it, you will get R, which is the internal radius, is equal to 75 inch. Now we can say that R outer is equal to inner radius plus thickness of plate. So inner radius is 75 plus thickness is 0.5 inch. So R outer is 75.5 inch. So outer radius is equal to 75.5 inch is required to maintain internal pressure of 200 psi and allowable stress of 15 ksi. So this was answer of our question number 8-2. I hope you have enjoyed it. Thank you for watching. Welcome back. Problem 8-3. The statement is that the thin wall cylinder can be supported in one of the two ways as shown. So this is first way, that is represented in figure A, and this is the second way, that is represented in figure B. Determine the state of stress in the wall of cylinder for both cases. If piston P causes the internal pressure to be 65 psi, the wall has a thickness of 0.25 inch and inner diameter of cylinder is 8 inch. So let's start with the given data. So in given data, it is given that this is thin wall cylinder, thin walled cylinder, okay, and internal pressure P is given as 65 psi, clear. The thickness of wall is equal to 0.25 inch, clear, and inner diameter, which is di, is equal to 8 inch. So from inner diameter we can get inner radius if we divide 8 by 2. So 8 by 2 is equal to 4 inch. So what we have to find is to find the state of stress in the wall of cylinder. So sigma 1 and sigma 2. Sigma 1 is hoop stress and sigma 2 is, I will write hoop stress, and sigma 2 is longitudinal stress. For both the cases. Here, so let's start with the solution. So for case A, you can see case A. So here you can see that longitudinal stress for thick wall cylinder is equal to sigma 1, that is equal to P into R divided by T. Clear? So P is 65 psi, inner radius is 4 divided by T is 0.25, and that comes out to be 1.04 ksi. So 1.04 ksi. I don't know what's 04 ksi. Okay, and longitudinal stress in this case will be equal to 0 because this is supported at this position. Now for case B, same sigma 1 is equal to P into R divided by T, and P is equal to 65 psi. Inner radius is 4 divided by thickness is 0.25, that is again equal to 1.04 ksi. But you can say this is the end of this cylinder is supported at these two positions, clear, and here longitudinal stress will be equal to P into R divided by 2T. So 65 into 4 divided by 2 into 0.25, and that will be equal to 520 psi. Or you can simply take that longitudinal stress is equal to half of hoop stress, so half of 1.04 ksi will be equal to 520 psi. So this was the answer of our question number 8-3. I hope you have enjoyed it. Thank you for watching. Welcome back. Problem 8-4. So the statement is the tank of the air compressor is subjected to an internal pressure of 90 psi if internal diameter of tank is 22 inch and the wall thickness is 0.25 inch. Determine the stress component acting at point A. Draw a volume element of the material at this point and show the result on the element. So this is the compressor. You can see you have been asked to find the stress component at this point. So let's start with the given data. So in given data, this is given as a tank. You can see that is cylindrical tank. So I will write cylindrical tank, clear, and the internal pressure is 90 psi. So P is equal to 90 psi. If the internal diameter of tank is di is given as 22 inch, so surely from here you can get inner radius which is equal to di divided by 2, and that is equal to 11 inch. Wall thickness is given T is equal to 0.25 inch, clear, and you have been asked to find the internal to determine the stress component acting at point A. So by stress component we mean sigma 1 and sigma 2, clear. So sigma 1 is hoop stress and sigma 2 is longitudinal stress. So let's start with the solution. So as we know that hoop stress is equal to P into R divided by T, and longitudinal stress is equal to P into R divided by 2T. But first we have to check whether this is thin wall pressure vessel or thick wall. So first to check for thin walled, so what we have to do is we have a condition that R by T is should be greater than 10 for thin wall pressure vessel. So you have R is 11, so 11 divided by 0.25 should be greater than 10, and this value comes out to be 44, and 44 is greater than 10, so it means that they are thin walled pressure vessel. Now you have to find the hoop stress, that is sigma 1. I will write hoop stress, that is sigma 1, and that is P into R divided by T, where P is the internal pressure, that is 90 psi, clear. R is inner radius which is 11 inch, clear, divided by thickness is 0.25 inch. So when you calculate it, the hoop stress comes out to be 3.96 ksi. Okay, for longitudinal stress, we have formula sigma 2 is equal to P into R divided by 2 into T. So you have all the values. P is 90 psi, Our inner radius is 11 inch. 2 multiplied by thickness is 0.25 inch. So when you calculate it, it will be 1.98 KSI. Again, if you know that longitudinal stress is equal to half of hoop stress, so 1 over 2 is equal to sigma 1, which is 3.96, and when you calculate it, it will be 1.98 KSI. So whether you are using this formula or this formula, they will give you the same answer. So this was the stress component acting at point A. So what if I draw this component at point A? So this is the component there. This is the component at A. So your longitudinal stress will be in this direction, clear, that is equal to sigma 2, and your hoop stress will be in this direction. This is sigma 1, and sigma 1 is equal to 3.96 KSI, while sigma 2 is equal to 1.98 KSI. So this was the representation of volume element of material at point A, clear, and the results are also shown. I hope you have now clear understanding. Thank you for watching. Welcome back. Problem 8-5. The statement is that open-ended polyvinyl chloride pipe has an inner diameter of 4 inch and thickness of 0.2 inch. If it carries flowing water at 60 psi pressure, determine the state of stress in the wall of pipe. So you can see this is a polyvinyl chloride pipe that is open at both ends, clear, and the rest of given data I will write it over here. This is for problem 8-5, clear. So given data is that the inner diameter first it is open-ended polyvinyl chloride. It is better to write each and every information in the given data, so you can easily get the information from it. Inner diameter di is equal to 4 inch. So here from this inner diameter we can get inner radius, which is equal to 2 inch, because di divided by 2 is equal to 4 divided by 2, which is equal to 2 inch. Clear. Thickness is given as 0.2 inch, clear, and pressure of water that is flowing inside the pipe is 60 psi. So you have to find the state of stress. So state of stress means you have to find the hoop stress as well as longitudinal stress. Hoop stress and longitudinal stress. So let's start with the solution. So as we know that hoop stress is equal to P into R divided by T. So you have P, which is 60 psi, you have R, which is equal to 2 divided by thickness is 0.2 inch, clear. So when you calculate it, you will get hoop stress is equal to 600 psi. Now what about longitudinal stress? So you can see the pipes are open. So as it is open-ended pipe, so in that condition sigma 2 will be equal to 0. So this was the answer of our question 8-5. Now we will move toward question 8-6. So if the flow of water within the pipe in problem 8-5 is stopped due to closing of valve. Now the rest of data will be the same because it is given over here that it is the same problem 8-5, but now the flow of the pipe is closed due to valve. So if the flow of water is closed due to valve, here determine the state of stress in the valve of pipe, neglect the weight of water, assume the support only exert vertical forces on the pipe. So in that case you will have the hoop stress sigma 1, which will be equal to P into R divided by 2T, and that will be equal to same 60 into 2 divided by 0.2, and that is equal to 600 psi. Now the pipes are closed due to closing valve. So in that condition your hoop longitudinal stress will be there, and that is equal to P into R divided by T. Okay, one thing is that this hoop stress is PR divided by T, not 2T. Clear? So, and this longitudinal stress is P into R divided by 2T. So 600 multiplied by 2 divided by 2 into 0.2. So when you calculate it, you will get 300 psi. Or you can also calculate sigma 2 is equal to half of sigma 1. So 600 divided by 2 is equal to 300 psi. So I hope you have enjoyed both the problems, and thank you for watching and supporting me. Welcome back. Problem 8-8. The steel water pipe has an inner diameter of 12 inch and wall thickness of 0.25 inch. If the wall A is open and the flowing water is under gauge pressure of 250 psi, determine the longitudinal and hoop stress developed in the wall of pipe. So you can see this is the pipe, this is wall A, and it is given that if wall A is open, determine the hoop stress and longitudinal stress. So let's start with the given data. This is problem 8-8. So given data, it is given that steel water pipe having diameter of 6 inch inner diameter. So DI is equal to 12 inch. So implies that inner radius RI will be equal to 6 inch, and wall thickness T is given as 0.25 inch, and water flowing is under gauge of 250 psi. So pressure is equal to 250 psi. So what we have to find, determine the longitudinal and hoop stress. So to find sigma hoop, which is equal to sigma 1, and sigma longitudinal, which is equal to sigma 2. So let's start with the solution. Also it is given that if wall A is open, so wall A is open, so in that case we can say that sigma 2, which is equal to sigma L, that is equal to 0. Also for checking, for analysis of thin wall pressure vessel, whether this problem lies within thin wall or not, so we can check it by using criteria R over T should be greater than 10. So R is 6 and T is 0.25, that should be greater than 10. So you can see this will be equal to 24, and 24 is greater than 10. So it means that this is thin wall pressure vessel problem. This is there. Now we can find hoop stress sigma H, is equal to P into R divided by T. So P is 250 psi, R is 6 inch, divided by thickness is 0.25. So when you calculate it, you will get this is equal to 6000 psi. Our sigma hoop is equal to 6 ksi. So sigma 1 is equal to, this is equal to sigma 1. So sigma 1 is equal to sigma hoop stress, and that is equal to 6 ksi, where longitudinal stress in this case that is equal to 0. Now we move toward the problem 8-9. So in problem 8-9, the data is same. Diameter, inner diameter is 12 inch, wall thickness is 0.25 inch. Now it is given that wall A is closed. So wall A is closed and the water pressure is 300 psi. So P is equal to 300 psi. So you have to determine the longitudinal and hoop stress developed in the pipe. So to find sigma 1 is equal to sigma h and sigma 2 is equal to sigma longitudinal. Clear? And you have also draw the state of stress on the volume element located on the wall. So let's start with the solution. So we know that sigma 1 is equal to sigma h is equal to P into R divided by T. So P is 300 psi, R is 6, divided by T is 0.25. So when you calculate it, you will get sigma 1, which is hoop stress, that is equal to it will be 7200 psi, and that is equal to 7.20 ksi. So this is sigma 1 or sigma hoop, and sigma longitudinal is P into R divided by 2T. So P is 300, R is 6, divided by 2 into 0.25, and that sigma 2 is equal to 3.60 ksi. Also, if you divide sigma 1 by 2, which is equal to 3.060 ksi, and that will be equal to longitudinal stress. There. Now we have both these two stress. You can draw the state of stress on the pipe element. So if we cut some portion of this, so I will draw it. Here, so your longitudinal stress will be in this direction. It is sigma longitudinal R is equal to sigma 2, and that is equal to 3.60 ksi, while your hoop stress will be in this direction. That is equal to sigma 1 is equal to sigma h, and that is equal to 7.20 ksi. So I hope you have enjoyed this video. Thank you for watching and keep supporting me. Take care. Welcome back. Problem 8-10. The A36 steel band is 2 inch wide and is secured around a smooth rigid cylinder. So you can see this is the band layer that is secured around a smooth rigid cylinder. This is cylinder. Clear? If the bolts are tightened so that the tension in them is 400 pound, so due to tightness of this bolt, the tension is 400 pound. Determine the normal stress in the band, the pressure exerted on the cylinder, and the distance half the band stretch. So let's start with the given data. In given data, it is that this is A36 steel layer, that is width W is equal to 2 inch layer, and thickness is given as 1/2 8 inch. That is again over here. The diameter of this cylinder is 8 inch. Clear? And tension, which is equal to force. Clear? That is tension F is equal to 400 pound. So what we have to find is that we have to find the normal stress sigma. Clear? Normal stress. Here we have to find the pressure exerted on the cylinder, and the 3 is the distance how the bend stretches due to this tension, how much this bend stretches, that is change in length. So let's start with the solution. As we know that normal stress is equal to force per unit area. So again this force is equal to 400 pound here, divided by the area of this band will be equal to thickness into width. So 2 into 1 by 8 inch. So when you solve this, you will get the normal stress is equal to 1600 psi. Now this is the normal stress, and again we can find our normal stress or working stress, and we know that hoop stress is equal to sigma 1, that is equal to P into R divided by T. There, and this normal stress is equal to sigma 1. So here 1600 psi is equal to P into R divided by T. So you can get P internal pressure, that is equal to 1600 into T divided by R. So 1600 multiplied by thickness is 1 by 8 inch. Okay, 1 by 8 inch divided by R is equal to the inner radius, which is 8 divided by 2, and that will be equal to 4. So this is the this is 8. This Ri is 8. This is not diameter, this is radius. Ri is 8 inch. So again you have to put 8 over here. So when you calculate it, you will get the internal pressure or pressure exerted on the cylinder, that is equal to 25 psi. So this is the answer of part B. Now we have been asked to find the distance half the bend stretch. So you have to take the half of the bend, that how much it stretches. So as we know that stress is equal to E into strain. Clear? So sigma 1 is equal to E into strain. Clear? And from here you can get E1 is equal, epsilon 1 is equal to strain stress over E. Now if you check at the end of the book property for A36, you will get this value of E. I will write it, sigma 1 is equal to 1600 psi, and E for A36, structural steel, you have E is 29 into 10 to the power 6 psi. So you can put the value 29 into 10 to the power 6. So you will get the strain is equal to 55.17. 2 into 10 to the power minus 6. Now we know that strain is equal to change in length divided by original length. Clear? And this change in length will be equal to epsilon 1 into original length. Epsilon 1 is equal to 55.172 into 10 to the power minus 6, and the length of this half segment will be equal to pi into this 8 this half segment will be equal to pi into 8 plus this thickness plus this thickness, which is 1 by 16. Okay, so half, because pi r, half is pi r, clear? So 8 plus this thickness and this thickness, so total is pi r, pi into r, clear? But this r should be outer radius, so 8 plus 1 by 8 plus 1 by 8 plus 1 by 16, clear? This is 1 by 8, thickness is 1 by 8, so 8 inch pi into r plus 1 by 6, 1 by 16. I think this is 1 by 8, 8 plus 1 by 8. So again you can put the value of length over here, so that will be pi into 8 plus 1 by 8. So when you solve this, you will get this change in length or the bend stretches comes out to be 0.0014 inch. So this is the answer. This is the normal stress, this is the pressure exerted on the cylinder, and this is the amount of bend that stretched due to this tension. I hope you have enjoyed it. Thank you for watching.